So we continue with lesson 2.5, discrete source coding algorithms. And at this point, we now discuss an alternative to Huffman coding, which is called the Shannon-Fano coding, or let's call this as the SF coding. Okay, let's use SF coding for this algorithm. Okay, so it is not only the Huffman coding that can generate compact codes. Okay, SF coding can also generate compact codes. Okay, magkaiba lang ng approach yung Huffman coding with SF coding. Okay, remember or recall in Huffman coding that you are combining probabilities, the two lowest probabilities, okay, into a branch, okay, of your code tree. Okay? Ito namang SF coding, actually medyo baliktad. Ang gagawin ng SF coding is actually you start by dividing your alphabet such that dividing your alphabet into two groups such that the two groups would have almost equal probabilities. Okay? Tapos yung division na yon or yung pagkakahati-hati na yon would be made smaller and smaller. Okay? Until you'd be able to arrive at each of the probabilities for the message. Okay? So ito yung steps of the algorithm. So for a given list of messages, construct the list of probabilities of message occurrence. And usually, this list, okay, must be arranged in decreasing order. Ganun din, decreasing order din. Okay? So, now, so yun na nga, ito pala yung reorder in decreasing order of message probabilities. Okay? Now, ito yung sabi ko kanina. Divide the list of messages into two sets. Okay? So, in such a way, okay, that the sums of probabilities are either identical, okay, or as close to each other as possible. So, kung hindi man natin ma-achieve na identical siya, we would like it to be as close as possible. Okay? So, yung dalawang sets na yun, we will call it as W0 tsaka W1. Okay? Now, create 1-bit prefixes of code words for messages, okay? Setting them to 0, related for code words related to messages contained in set W0, okay? And to 1, okay? For code words related to messages contained in set W1. Ang ibig sabihin lang nun is that after dividing the list of messages such that the divide or the two groups would have almost equal probabilities. Okay, yung isang grupo doon i-assign natin with a 0, okay, as part of its code word, and the other one, okay, is 1. Okay, so yun. Now, you apply the algorithm recursively, okay. So by dividing it into subsets, okay, and adding subsequent bits to the code words created, okay, until all the subsets contain single messages. So until such time na meron na tayong codes para sa bawat isang message, then that's the time we will stop the algorithm. Okay? So yun yung SF coding natin. So medyo opposite approach siya ng Huffman coding, wherein ang Huffman coding yun looks into the into the letters having two lowest probabilities of occurrence. Ito naman, hinahati natin yung probabilities natin, okay, into almost half and almost half. Okay, into half. Okay, parang hahatiin natin siya such that magkakalahati yung mga natin. Okay? So, ayun. That's SF coding for us. Okay? So para ma-demonstrate natin siya ganito, no? So if this is the probability distribution of your DMS. Okay? So 0.3, 0.2, 0.15, 0.15, 0.15, and 0.05. Okay? Let's construct the list of probabilities. Okay? For each message. So you would have the following. Now, make sure that the list is ordered in such a way that the message probabilities are in decreasing order. So, yun. Yung probabilities nito pababa. Okay? So, now, on the first iteration, yung probability distribution nito, hati natin sa dalawang grupo. Okay? In such a way that the sum of probabilities in each group, would be almost equal. Or, ang target is dapat equal. Pero kung hindi pwede, almost equal. Okay? So, in this case, yung A1 at saka A2, okay, yung messages A1 and A2 has a combined probability of 0.5. While the messages A3, A4, A5, and A6 has a combined probability of 0.5. So, yun yung dalawang grupo natin ngayon. Okay? So, the two groups are yung A1, A2, which is we will call the set W0. Okay? While yung set A3, A4, A5, and A6 would be called set W1. Okay? So, we will now assign the codes 0 and 1 for those sets. Okay? So, yung set W0 which contains A1 and A2 will be assigned the code, the symbols 0, while as part of their code word, okay, while the set A3, A4, A5, A6, okay, which is under ng W1, okay, will now have the symbol 1 as part of their code word. Okay, so that's on the first iteration. Ngayon, so meron ngayon tayong dalawang grupo titingnan, no? So yung grupo ng W0 at the start, which is A1 and A2. Okay? A1 and A2. And then yung pangalawang grupo natin, which is W1, okay, which is A3, A4, A5, and A6. Okay? So now, on the second iteration, we will proceed as follows. Okay? So, ang probabilities nito, isusulat natin ulit, no? This is 0.30. This is 0.20. For A3, this is 0.15. A4 is 0.15. A5 is 0.15. And A6 is 0.15. Okay? So, for each group, okay? For each group na nahati na natin, okay? We will further subdivide each group, okay, into two, so that the sum of the probabilities for each is almost identical. Okay? So in the case of W1, okay, or W0, okay, since A1 tsaka A2 to, then yung hatian niyan is the A1 and A2 themselves. Okay? So yung kasi yun na yung dalawa eh. Almost equal na tong 0.3 tsaka 0.2 eh. So mahahati na sila sa dalawang grupo ngayon. Okay? So ito na ngayon yung tatawagin natin sa second iteration. This will now be called as W0 and W1. Okay? So, ito yun. Ito yung magiging bagong W0. Okay? And W1. Okay? While on the W1 group, okay, hahatiin natin itong mga probabilities ito such that the sum of probabilities would be almost equal. So, in this case, we can divide this along this line. Okay? Along this line. Because yung sum of probabilities dito, okay, yung sum of probabilities nitong dalawang to is 0.3. So, 0.3 yung magiging sum probabilities niyan. While ito, yung sum probabilities nito would be 0.2. Okay? So, almost equal probabilities. Yan na yung best na makukuha natin. Okay? So, under ng W1, okay, we will consider this group, okay, to be W0, while itong A5, A6 would be under W1. Okay? So, what will happen now to the codes? Okay? So, on the first iteration, inassign natin yung symbol 0 para sa W0. Okay? While the symbol 1 for those belonging in W1. Okay? So, after the second iteration, ito na yung updated codes ng bawat isa. Okay? So, this is the code after second iteration. Okay? So, since sa una, inassign natin na 0 itong grupo na to. Okay? We have assigned 0 for this group, while 1 for this group. Okay? Sa second iteration kasi, i-assign natin ngayon yung 0 para dito. So, for A1, okay, ang magiging code na natin ngayon is 0 and 0. So, ito na yung 0 and 0 para sa code ng A1. Okay? While for A2, we will have 0 and 1. Okay? So, we will have 0 and 1 as codes for A2. Okay? And notice na bawat dito sa grupo na to, okay, in this group, you already have unique codes for each of the messages. So, ibig sabihin, tapos na tayo mag-generate para ng codes para sa A1 tsaka A2. Okay? So, ito na yung official, magiging SF code nila. Okay? So, there. Now, while on this group, so sa una, we have assigned the symbol 1 for all these messages. Now, since nahati sila sa dalawang grupo ulit, okay, the group A3 and A4 would be assigned the symbol 0, okay, while A5 and A6 would be assigned the symbol 1. So, therefore, for this group, okay, so for this group, you now have the codes 1, 0, okay, for A3 and A4, okay, while for A5 and A6, you'll have 1, 1. Okay? So those are the codes after the second iteration. But remember that hindi pa tayo tapos para sa A3 and A4 kasi hindi pa unique yung code ng A3 tsaka A4. Nagsishare pa sila sa isang code. Same thing with A5 and A6, nagsishare pa sila sa isang code. Okay? So, we will proceed then to the third iteration. So, yun na nga. Ito na yung codes after the second iteration. Okay? These are the codes after the second iteration. Now, on the third iteration, okay, what will happen here is this. Okay? So, we're done with with this A1 and A2. So, okay na tayo dito. So, ito na yung titingnan natin. Itong grupo ng A3 tsaka A4, A5 tsaka A6. Okay. So, again, we list here A3 to have a probability of 0.15, A4 to have a probability of 0.15, okay, and A5 to have a probability of 0.15, A6 would have a probability of 0.05. 0.05 pala to, sorry. This is 0.05. Yan. Now, we will have to divide these groups, okay, into two. Again, depending on, basta magkaroon sila dapat ng almost equal probability. So, in the case of the group of A3 and A4, they can be divided this way. So, yun, equal yung probability nila. 0.15 and 0.15. Okay? So, while A5 and A6 can be divided this way. Kasi wala na tayong magagawa dyan dahil dalawa lang naman talaga sila. Okay? So, yun. So, now, in the third iteration, we will assign this to be the set W0, while this is W1. Ito naman, ganun din, W0 to, W1 ito. Okay? So, those would be the set division after the third iteration. Okay? So, ngayon, we are now ready to generate the codes after the third iteration. So, the codes after the third iteration, okay? Codes after third iteration. Okay. So, ang gagawin natin is that since we have already assigned A3 and A4 with the codes 1, 0 at the start. Okay. And then finally, for A3, we will assign the symbol 0 because it is part of W0 as a group. Okay. While A4 would be assigned the code, initially it was assigned the code 1, 0. Okay. Pero this, at the third iteration, idadagdag natin yung 1 as a symbol. Okay? So, now, we're done with this, with A3 and A4 kasi may unique codes na pinaging bawat isa. Okay? So, we're done with this. Okay, so okay tayo dito kanina, okay tayo dito. Then finally, we see that A5 and A6 are both assigned the codes 1, 1 each. But in this third iteration, we see that A5 would assign additionally with the symbol 0, while A6 would be assigned additionally as the symbol 1. Okay, because of this division of W0 and W1. So now, since you have a unique code for A5 and unique code for A6, you're done also with this group. Okay? So, after the third iterations, you now have unique codes for each of your messages. So, these codes are summarized here. Okay? Ito na yung magiging codes ninyo. Or specifically, we call this as FF codes. Okay? So, after the third iteration, after 3 iterations of SF algorithm, all messages now have their respective SF codes. Okay? So, there. So, we can actually demonstrate or we can actually illustrate the SF algorithm, okay, for using a code tree. Yung implementation ng SF algorithm or synthesis ng SF code using this code tree. Okay? So parang let's start with this one. We list all the probabilities for each of the letters. So you have A6, A5, A4, and A3 having the probabilities 0.05, 0.5, 0.15, 0.15, and 0.15 respectively. Also, you have A2 and A1 there, which has a probability of 0.2 and 0.3 respectively. Okay? Now, if you add the two, okay, pag in-add natin ito, tsaka to, okay, that leads to a probability of 0.2, while this here, if you add these two, that would lead to a probability of 0.3. Okay? So, same thing, if you add these two, you'll have a probability of 0.5. Okay? And then, these two, you'll have a probability of 0.5. Then, overall, pag in-add nyo to, you'll have a probability of 1. So, that's the topmost node. Okay? So, this is the primary node or the starting node of your code tree. Okay? So, from the starting node, you assign 0 to the left and 1 to the right of left branch and right branch of your code tree. Okay? So, ayun. We actually start from the bottom here kasi nagsisimula tayo sa mga probabilities eh. Okay? So, actually kapag i-generate nyo to using code tree, ito yung parang magiging talagang magiging sequence niya. Okay? Kasi at the start, you won't really think of actually elevating these two eh. Hindi natin kagad may isip talaga na i-elevate yung dalawang to. Okay? Although, alam natin na pwedeng gawin yun, kaya lang kasi, pwede natin hindi siya maisip kagad. Okay? Unless ang protocol natin in the implementation, in the construction of code tree using SF algorithm, iba-ibahin natin yung levels of our nodes depending on their probabilities. Pero sa una, medyo mahirap gawin yun. So, let's just simply, write all of them on the same level. Okay? So, you'll have 0.3, 0.2. Okay? You have, ilang 0.15 yung tatlo? 0.15, 0.15, 0.15, and then 0.05. So, you start with that one. Let's start with this one. Okay? So, bilugan natin. So, we'll have the following nodes, 0.3, 0.2, 0.15, 0.15, 0.15, and 0.05. Okay? So, again, in the SF algorithm, we have to divide this into two, such that the sum of probabilities of the two groups are almost identical. Okay? So, in this case, that would involve adding these two. Okay? These two nodes, the probabilities of these two nodes. Okay? So that it becomes 0.5. Okay? And then adding these probabilities. Okay? So we start with this one. So again, we group your messages into two groups, this group, okay, and this group, okay, so that these two groups would have identical probabilities. Okay? Now, on the next step of the SF algorithm, we have to divide, since this is already divided, this two is already divided kasi nasa second level na tayo eh. Okay? So, this is already divided. So, this is already done. Okay? So, done deal na tong dalawan to. Okay? Ang titingnan natin itong apat na to, itong second group natin, which still does not have codes for each. Okay? So, ngayon, ang gagawin natin is to, again, divide this into two groups. Okay? So, those two groups must be these two. Okay? Yung division ng groups na yun must be these two groups. Itong grupo na to, tsaka itong grupo na to. Okay? So that, we will have the combined probability of these two as 0.3. Okay? So, ito yung dalawang yun. While for this, you would have 0.2 as the combined probability. Okay? For this. And still, check that 0.3 plus 0.2 is still 0.5. Okay? So, now that these two now are divided into the two, okay, which is 0.15 and 0.15, and this one is 0.15 and 0.05, we now have the codes for each. Okay? We just have to add the top branches. Okay? So that we start the we have the top node here. Okay? Where we will now assign the codes. 0 on the left branch, 1 on the right branch. 0 on the left branch, 1 on the right branch. 0 on the left branch, 1 on the right branch. 0 on the left branch, 1 on the right. 0 on the left, 1 on the right. Okay? So that if this is now x1, x2, x3, x4, x5, and x6, okay, we will now have the following codes. For x1, we will have 0 and 0. For x2, we will have 0 and 1. For x3, we will have 1, 0, 0. For x4, we will have 1, 0, 1. For x5, we will have 1, 1, 0. And for x6, we will have 1, 1, 1. So this will be the SF codes. Okay? That is generated based on A code 3. Okay? So again, it involves grouping this first into these two groups so that their probabilities are 0.5 and 0.5. Okay? So next is to divide these two into another two groups so that the sum of the probabilities will be almost identical. Okay? And then that. Okay? So you can also use tables to implement SF codes. Okay? Now, let's characterize your SF codes. Okay? For the SF codes for this CMS. So these are the SF codes. Okay? So if we compute the entropy for this source, that should give us again the entropy is negative 0.3 times logarithm of 0.3 to the base 2 minus 0.2 times logarithm of 0.2 to the base 2 and so on. So you have to compute the entropy galing dito sa probabilities. Now, in terms ng SF codes, okay? Kunin natin yung R bar niya, okay? Again, R bar is obtained using the formula, the summation of nk times the probability for each message. Okay? So, A pala yung ginagamit niya, no? X yung ginamit ko dun sa example ko. Anyway, so, ito. This should be A. Okay, so yan. Again, let's have nk for this SF code. So the nk for the SF codes are 2, 2, 3, 3, 3, and 3. So therefore, ang R bar nito, okay, would be computed as 2 times 0.3 plus 2 times 0.2, okay, plus tatlo to, 1, 2, 3. So 3 times 3, that's 9 times 0.15, okay, plus 3 times 0.05. 0.05. So again, please verify that you would be able to get the average code word length as 2.5 bits per message. So this is your entropy, okay, and this is your average code word length. Okay, the efficiency, again, is computed as 100 times the entropy divided by R bar. So verify that it becomes 97.3%. Okay, so there. Now, if you actually generate a Huffman code, okay, if you actually implement the Huffman code using these probabilities, you would be able to have the following codes. You would have the following codes here. Okay, pansinin niyo lang na medyo may pagkakaiba lang ng konti in terms of this and this. Pero the rest of the codes are the same. Okay? But again, if you would notice, the set of code word lengths for the Huffman code is the same as that of the SF code. So which means that that both SF code and the Huffman code would give or would result to an R bar of 2.5 bits per message. Pareho yung i-generate nitong R bar. Okay? So again, Huffman code is not the only algorithm that would generate compact codes. Hindi lang Huffman code ang may kakayahang mag-generate ng compact codes. Okay? So there. So a Huffman code generated, okay, for the same DMS, okay, returns the same set of code word lengths NK, and therefore would result in similar R bar and efficiency. Okay? So that's SF coding for us. So the next algorithm that we will study is the dynamic Huffman coding. Okay? So in Huffman or Shannon-Fano source coding algorithms, the statistics of source messages are taken into account. Okay? But how do we know? Okay, how do we know these statistics? How do we know these probabilities ba? Okay, in practice. So in practice, blocks of messages such as data, text, single pictures, or video sequences featuring different statistics are the objects of coding. Okay? So, since kailangan natin ng probabilities. Okay? Dalawa yung source nung statistics nung message probabilities natin. Okay? Una, your messages or your decoder, okay, and encoder have an initial or conducts initial analysis of the message sequences to be encoded. So meaning nagko-compute siya ng the encoder, okay? The encoder generates probabilities based on the generated messages by the source. Kumbaga, ang nagdedetermine ng probabilities of the messages generated by the source is at first the encoder itself. Okay? So, gumagawa siya ng initial analysis. Okay? So, habang dumadami yung messages that the source generates, ina-update ng encoder yung values of probabilities niya. Okay? So, ibig sabihin nun, the encoder always has the task of computing probabilities. So, ibig sabihin nun, okay? Or anong implication nun? Kasi para makapag-compute ka ng probabilities, you need to count the number. For example, kung meron kang certain message, and you want to say, for example, no, the probability that the letter E would appear on a certain message, okay? Then, halimbawa lang ito. Itong nakikita nyo lang na text dito sa ating dito lang. Okay? Yung nakikita nyo yung text sa current part ng presentation natin. Okay? Ang gagawin nyo dyan, bibilangin nyo lahat ng letter E dyan. Okay? So, halimbawa, nabilang yung letter E dyan, sabihin natin 100. Tapos, bibilangin nyo kung ilan lahat merong letters dito. So, halimbawa, sabihin natin na meron tayong mga 650 na letters dyan. Huwag na 650, mga 600 naman. Okay? So, therefore, the probability of your message having E as a letter, okay, is 1/6. Okay? So, yun yung initial probability na ibibigay, i-assign ng encoder ninyo dun sa E. And gagawin niya yan sa lahat ng letters na makikita niya dito. Okay? So, yun ang mangyayari diyan. Yun ang magiging trabaho ng encoder ninyo. Okay? So, which means at the start, the encoder is actually starting to compute the probabilities based on the message generated by the source. Okay? Now, what if another set of messages come out of the source? Halimbawa, yung second part nung ating presentation. Isasama natin siya dun sa messages generated by the source. So ngayon, since may mga bagong letter E dyan, okay, and malamang yung occurrence ng E dyan ay iba dun sa occurrence ng E dun sa una. Ang gagawin ngayon ng encoder nyo is i-update niya to, yung probability na to. Not just for E, but for all the letters that it would see here. Okay? So, ang mangyayari ngayon is that itatago yung encoder nyo, itatago lahat ng list of probabilities niya on a memory. And then i-update niya yan once may lumabas na mga bagong messages. Okay? So, ganun yung proseso ng Huffman encoding. Okay? So, especially kapag we don't really know the probability of occurrences, okay, of each letters. For example, in this message. Not unless meron talagang ginawang study, for example, that actually resulted in the probability of occurrence of a letter for all possible English words that can possibly be inside a certain message. Okay? Then static na yung list of probabilities ni encoder. So, okay 'yun pagka ganoon. Pero kapag hindi, ang ginagawa ni encoder is that it computes for the probabilities based on the messages that it has. Okay? So ngayon, ganito mangyayari diyan. Once na magpalit siya ng probabilities, malamang baka magpalit din siya ng codes. Okay? Kasi again, nakadepende ang code sa probabilities. Okay? So, ayun. So, here's the thing. The necessity of double analysis of the message block to be encoded is disadvantageous. Kasi double analysis of the message block means you're looking at the message block, okay, for the probabilities. Then, after that, you'll again look at the message block para i-encode mo siya. So, dalawang beses mong tinitingnan yung message block lagi. Okay? Kapag ganun yung sistema nung encoder mo. Okay? So, it is disadvantageous because the processing requirements increase. Okay? So, an additional problem is the necessity to supply the decoder. Okay? So, ang gagawin mo rin kasi is that si encoder, kailangan i-send niya yung source stat. Okay? Kasi si decoder, kailangan niya rin mag-generate ng codes para ma-decode niya yung message. Okay? So, o kaya, pwede rin namang kung hindi source statistics yung isi-send ni encoder, pwede naman siyang mag-send ng codebook. Okay? But still, what happens is that the decoder still needs to have an idea, okay, on either the source statistics or the generated code. Huffman code for the current set of messages. Okay? So this was the motivation for developing a coding method that does not require double browsing of the message block. Okay? and allows for independent estimation of the source statistics, both at the source encoder and at the decoder. Okay? So, that coding method is what we call now the dynamic Huffman encoding. Okay? So, in dynamic Huffman coding, ina-address natin dito yung difficulty of the encoder to 1. Again, ang naging problema natin with the conventional Huffman coding or yung static na Huffman coding is that number 1, the encoder looks at message blocks twice. Okay? So, yan yung first problem natin with the static Huffman coding. Now, the second problem is that the decoder depends on the encoder to send either the source statistics, okay, or the generated codebook, okay, so that it can decode the messages. Okay? So, yun yung problema doon. So, maghihintay lagi si decoder kay encoder para sa either sa dalawang ito. Okay? So, those are the problems with the static Huffman coding. Now, the dynamic Huffman coding actually addresses both of those problems. Okay? So, sa dynamic Huffman coding, it does not require the encoder to inspect the message twice. And it also allows for the decoder to independently check on the message statistics, and this will not be required or compelled to wait for the encoder to send source statistics. Okay? So yun yung ina-address ng dynamic Huffman coding. So we will demonstrate the operation and the algorithm of dynamic Huffman coding using an example. Okay? Which here we will encode a text. Okay? We will encode a text. Now, in the presentation of the example, yung given text natin are given as text talaga. Okay? Pero remember that texts, okay, or letters of text are encoded as ASCII. Okay? They are encoded as ASCII. So, ibig sabihin, for example, kung meron tayong letter T na makikita, i-convert natin yan sa kanyang ASCII code. Okay? So, it's a 7-bit, binary digits of code word. Okay? Code word. So, yun. Pero dito sa presentation, i-represent natin siya as T kasi may isulat pa natin yung buong ASCII code for T. Okay, so here. So, let's encode the sequence, this is mom. So, meron tayong dalawang space, which is represented here as underscore. Okay? So, in each step, we will discuss, okay, the step, and then we will present the code tree. Okay? So, remember, in the dynamic Huffman coding, both the encoder and the decoder construct a code tree. Okay? Pareho sila nagko-construct ng code tree as they receive the message. Okay? So, initially, we start the code tree that contains a single branch with a zero leaf, okay, as at its end, and denoted by the symbol EP. Okay? Ito. Let's just read this as E. Okay? Yung symbol kasi na to would actually mean na that branch of the code tree is terminated. So ibig sabihin wala nang susunod diyan. Okay? So 'yun. So in general, leaves terminating each branch are marked, okay, by the symbol xn. Okay? So where x denotes the message, okay, and n is the number of its appearances from the start of the encoding process. So which means, tinetrace that din natin kung ilang beses nag-a-appear ang isang letter, okay, sa ating message. Okay? So, for example, meron tayong message na say T. Tapos, say for example, 4 na beses siya nag-a-appear sa ating message since the encoding process. So, a branch for that would be represented by T4. Okay? So, mamaya makikita natin yan. Okay? So, yun. So, as previously, a branch growing in the left direction is assigned a code symbol 0. Okay? While a branch directed to the right is assigned 1. So, yun yung assignment ng symbols natin sa code tree natin. Okay? So, at the start of the so again, meron tayong yung code tree natin would start having a left branch, okay, terminating at E. Okay, so since wala pa tayong message. Okay, now, the encoder starts from encoding the message T kasi this is mom yung i-encode natin. So, we'll start with the message T. Again, this T is actually represented in an ASCII code. Okay, now, as this message occurs for the first time, okay, so in that case, the decoder, okay, receives it as an ASCII code word. Okay, so since first time siyang na-encounter sa message. Okay, so now its occurrence now in our code tree, okay, will be denoted by the symbol T1. Okay, so yung T is the message, 1 is the number of occurrence since encoding. Okay, so there. So in each step, besides tree modification, okay, the list of nodes and leaves is created. Okay, so we will create a list of nodes and leaves. Okay, picking them up, okay, from the left of the lowest tree layer to the right. Okay, so yun. And repeating the same move, shifting to the higher three layers. Okay, so in this first step, since nag-generate tayo ng message na T, okay, magba-branch out ngayon yung ating code tree between this E at saka yung first message natin, which is T1. Okay? Now, the nodes of our code tree currently are these two. So, we read it from left to right. Pagka yung mga characters sa natin, yung node list natin is generated by reading the nodes, okay, from left to right. Okay? So, yun. Now, so this is the first step, or this is how our code tree looks after the first step. Okay. Now, in the second step, okay, in which now a new message H appears. Okay. So again, this is the letter H appears for the first time. Okay. So ang isa-send ngayon ng encoder ninyo dun sa decoder is yung ASCII code for the character H. Okay. So ayun. Okay. Now, saan ngayon napupunta yung sa code tree natin yung Saan napupunta ngayon yung natin sa code tree? Okay. So, at the start, ito yung code tree natin. Okay. Now, okay. So, once ma-generate ngayon yung character H, galing dun sa message natin. Okay. The encoder sends the ASCII code for H, pero dadagdagan niya yun ng 0. Saan niya nakuha yung 0? Ganito mangyari dyan. From this code tree, galing sa code tree na to, okay, itong node na to, okay, dyan magba-branch out yung new messages natin. So, pag may bago tayong message, dyan siya magba-branch out. So, which means ito, magpo-produce siya ng dalawang nodes, okay, which would contain on the left siya. So ibig sabihin itong E na to, bababa to. Okay? And then dun ngayon dito sa branch na to magiging dun ma-assign yung node para sa H. So we'll assign the message H1. Okay? For that one. Since H is the message, tapos yung 1 is the number of occurrence of H. Okay? Ngayon itong E na to, magiging ano yan? Magiging 1. Okay? Paano makukuha tong 1 na to? We will add the number, okay, of occurrence of this and this. But remember that this node is always assigned 0. Okay? Yung number of occurrence niyan is always assigned 0. So, while this, ang number of occurrence niyan is 1. So, pag in-add nyo yung 0 tsaka 1, that becomes 1. Okay? So, ngayon, again, since na-update na yung code tree natin, we will have 0 and then 0 sa left branch, 1 sa right branch. Okay? So, yun. Okay. Now, as I was saying tungkol doon sa isi-send ng encoder ninyo, so aside from the message H, it will also send the code 0. Okay? Yung 0 na yan, nakuha niya yan dito. Kung saan siya magba-branch out. Saan magba-branch out si H. Okay? So, since si H ay magba-branch out dito, so 0, tapos yung iba-branch out niya. Okay? So, ito ngayon yung code word na i-send ni encoder kay decoder. Okay? 0 tapos yung ASCII code para sa H. Okay? Now, let's see the updated code tree para sa para sa dynamic Huffman coding niyo. So again, this is always assigned as 0 occurrence. Ito 1. Okay? So pag in-add natin siya, 0 plus 1, ito yung makukuha nating node dito na 1. Okay? And then on the nodes list, we will have to generate the nodes list. Okay? Reading it from left to right. Okay? So we will have this one, E, then H, okay? And then 1, okay? And then T1. Okay? So, yun. Okay? Now, in the third step, okay, in the message I is to be encoded. Okay? So, again, ang gagawin nung ninyo, okay, is isi-send niya, okay, magsisend siya ng message na 0, 0, tapos yung ASCII code para sa I. Kasi again, dito magba-branch out yung bago yung mga messages. This is where your new messages would actually branch out. So, magsisend muna siya ng 0, 0, tapos yung ASCII code para sa I. So, eto yun. Add. Okay? So, that is what happened. That is what will happen. Next. So, since mag-branch out nga dito yung I, okay? So, dito ngayon napupunta yung E, tapos dito ang pupunta yung I1. Since this is the first occurrence of I, i-assign natin yung 1 para dito. Okay? So, now, this node now becomes 1. Okay? So, again, we'll assign 0 here and 1 here. So, kung natin ngayon yung code tree natin, okay? 0 here, 1 here, and then take note that this is 1 plus 1. Okay, so this becomes 2. Okay, so that becomes 2 now. Now, if we take a look at the nodes list, okay, natin, magiging ganito siya. Again, reading from left to right, then bottom to top. So, we'll have E, I1, okay, then 1, H1, 2, at saka T1. So, those are your nodes list. Now, ang kailangan ngayon sa nodes list niyo, tatandaan niyo to. Ang kailangan nyo sa nodes list ngayon is dapat naka-arrange to in increasing numbers. So, lahat ng numbers na makikita nyo, dapat naka-increasing order yan. So, ito, 0 ito. This is considered 0. 1, 1, 1, 2, tapos 1. So, ibig sabihin, baliktad to. Yung 2 at saka 1 ninyo. So, in that case, we will have to consider rearrangement of the nodes list and at the same time, the rearrangement of your code tree. Okay? I-rearrange din natin yung code tree natin. Okay? So, paano natin gagawin yung rearrangement? So, we simply arrange these nodes, okay, in increasing order of its number, assigned number. Okay? So, since ito, mas maliit ito kaysa dito, we'll just have to interchange them. So, pagpalitin natin itong si 2 at saka si T1. So, we'll have to interchange these two. Okay? So, that ang magiging nodes list natin or updated nodes list natin becomes E, I1, okay? We have I1, we have 1, H1, tapos T1, at saka 2. Okay? So, in doing so, dapat ganito ngayon yung maging itsura nung code tree ninyo. Okay? Yung magiging updated na code tree ninyo. Okay? We will have E. Okay? Tapos, I1. Again, reading the nodes list from left to right. I1. Okay? Then, kapag ito, yung dalawang yan, okay, kinombine natin on the single node. Okay? So, this is 0 plus 1. So, meron tayong node na 1 dito. Okay? So, that would be the node 1 na meron dito. Okay? Then, we can have H1 here. Okay? Teka lang. Hindi kakasya yung, yung code tree. So, again, we start with E. Okay? And then, I1. Okay? So that if we combine these two, we will have the node 1 here. Okay? We will have the node 1 here. Okay? So 0 plus 1. Okay? Then, so ito na yung 1, no? Okay? We can have H1 here. Okay? Okay? So we can have H1 here. Again, reading this from left to right, di ba? Left to right, tas 1, tapos ito yung H1. Okay? Then, we combine these two. So pag ina natin 1 plus 1, we will have 2 as the node here. And then, reading this T1 tsaka 2, then dito yung T1 ngayon. Tsaka yung 2. Okay? So if we combine this, we will have the top, the root of the tree, code tree. So ito ngayon yung magiging bagong assign codes niya. So 0, 1, again, left branch 0, right branch 1. So 0, 1, 0, 1, and then 0, 1. Okay, so yun yung magiging updated code tree natin. Okay, so ito yun. This one. Okay, kasi ito yung updated code list. Pero wala itong 2 na to. So tama ba? We have E1, I1, then we have 1, H1, 1, H1, and then T1, 2. Okay. So there, that's the updated code tree. Okay, for our after the third step. Okay. Now, sa fourth step, okay, in the fourth step, we will send the message S. Okay? And again, since the message S is the first time to be sent, okay, ang isa-send natin ngayon sa ating decoder is this code. 1, 0, 0. Tapos yung ASCII code para sa S. Okay? So, isa-send natin yung code na 1, 0, 0, tsaka yung ASCII code para sa S. Okay? Then, ilalagay natin ngayon dito, or idadagdag natin ngayon dito yung branch nyo para sa S. So, your code tree would be updated this way. Okay, your code tree would be updated this way. So, we start here. Okay, you'll have T1. Okay, then simulan natin sa bottom para Okay, so at the bottom, you'll have E. Okay, you'll have E tsaka S1 kasi bagong generate na message yan. Okay, so if you combine them on a node, that becomes 1. Okay, so dito yun. So magiging ka-level niya tong I1. So this becomes I1 now. Okay? And if we combine these two, okay? Magiging 2 ngayon yan. Tapos ito yung 2 na yun eh. Ka-level niya tong H1 na to. So this is H1. Okay? Again, pag kinumbine natin yan, that becomes 2 plus 1, magiging 3. Okay? And then, ito yung previously 2 siya, ngayon 3 na siya. Ito yung ka-level ni T1. So this is T1. Okay? So this would be the root of the code tree. Okay? So if we actually take a look at the nodes list, reading it from left to right, then bottom to top, so we'll have the following nodes list: E, S1, 1, I1, 2, H1, T1, and then 3, which is obviously not arranged properly. Okay? So, Again, kasi meron tayong 2 dito. Tapos meron tayong dalawang mababang number dun sa kasunod niya. So for us to do the rearrangement, we will have to interchange these two nodes. Kailangan pagpalitin natin itong dalawang to. Okay? So pagpalitin natin yan. So that the new nodes list should become E, S1, 1, I1, T1, tas H1, then 2, tapos 3. Although these numbers, itong 2 at saka 3 ito, may iba to. Okay? This will change. Okay? So that is why pagkatapos ng H1, let's not expect na meron pang 2 at saka 3 dyan. Okay? So what will happen now to our code 3? Okay? Using this rearranged nodes list. Okay? So and then we have we will have the top wait lang. Yan. So we now have this as our updated code 3. So again, nilagay natin yung mga ones. Okay, or yung mga nodes having 1 as their assigned number. Okay, on the same layer or on the same level of the code 3. Okay. So ngayon, mapapansin nyo ngayon, wala nang 3 dito. This is simply just 2. So magiging 2 na lang ngayon to. Okay. So this is now your updated nodes list. And the assigned codes now is 0 and 1 here, 0 and 1 here, 0 and 1 here, 0 and 1 here. So this is now your code tree after T, okay, H, I, S, okay. And remember na ang mga na-send you ng message sa decoder ninyo is first yung T, yung ASCII code para sa T. Next is 0, tsaka yung ASCII code para sa H. Okay? Then next is dalawang 0, so 0, 0. Then yung ASCII code para sa I. Okay? And then 1, 0, 0. Aba? 1, 0, 0. And then yung ASCII code para sa S. So ito na yung mga na-send yung mga messages or code words sa encoder as after S. Okay? So the next character after S, okay, is an underscore. Okay? That's an underscore. I mean the white space, okay, which we will represent as the underscore. So, ano yung isa-send nating message ngayon sa encoder? Okay? Since this is the first time that the white space appears, okay, ang isa-send nating message ay, again, dito siya mag-branch out. So, ang isa-send natin ay 0, 0, 0. Tapos yung underscore. Ay, yung ASCII code para sa underscore. So, 0, 0, 0. And then yung ASCII code para sa underscore. Okay? So, this is the message that we will be sending at this point. Okay? So, now, we will update now the code tree. Okay? We will update now the code tree. With the appearance of the underscore by, again, branching this E into 2. Okay? So, meron tayong E at saka meron tayong underscore 1 kasi first time niya mag-appear. So, again, these two combines to a node of 1. Okay? And if we take, and this one is updated to 2 kasi 1 plus 1 becomes 2. Okay? And then 2 plus 1, ito, magiging 3 ito. Yan. So, magiging 3 yan. Okay? So, yun yung magiging update sa code tree natin after the underscore message appears. Okay? So, tingnan natin yung nodes list natin ulit. Okay? Let's look at the nodes list from this code tree. So, you have E, underscore 1. You have 1, S1. You have 2, I1, T1, H1, 3, at saka 2. Okay? So, obviously, misarrange ulit yung node tree ninyo because this higher number 2 appears with a node that has a lower number assigned to it. Okay? So, ang kailangan natin dyan is pagpalitin natin siya. Okay? Let's interchange those two. So when we interchange those two, okay, we'll have the following. So you will have you will have E underscore 1. So may 1 siguro dyan. Okay, S1. Then we'll have H1 first, then I1, T1, and then 2, 3, 2. But these numbers are will be changed naman or will be updated once we have updated our code 3. Okay, so based dito sa nodes list na to, let's construct another code 3. Okay, so let's have your code 3 as the following. So let's start from this. Okay, so we have E, okay, and then underscore 1. Okay, so just remember that these two nodes combine for the one node here. Okay, so itong one node na to, ito yan. Okay, now yung next na ilalagay kong since this should go from left to right. So yung one na to, to the right of that one should go S1. Okay? But remember that if I actually add these two nodes, okay, magiging 2 yan. Okay? But these two, okay, remember that these two, kailangan mauna sa kanya yung T1, I1, tsaka H1. Okay? So which means that yung H1, mapupunta, this should be T1, okay, this should be I1, tsaka this should be H1. Okay, kasi kailangan yun yung, again, left to right, okay, bottom to top, yung arrangement ng code 3 natin. Okay, but since I have run out of space, ulitin ko na itong code 3 natin. So again, pag kinumbine natin itong node na to, 1 at saka 1, that adds up to this node 2 here. And again, looking at your nodes list, itong 2 na to, which is this, supposedly this one, nasa kaliwa pa niya yung T1, I1, tsaka H1. Okay? So you have T1 here, you have I1 here, and you have H1 here. Again, if you read these nodes, dapat left to right yan. Okay? So now, we combine these two. Okay? First, actually, these two, to have a node of 2 here. Okay? Because 1 plus 1 is 2. Okay? So we'll have 2 here. Okay? And then we have 1 plus 2 here. So we'll have the node 3. Okay? So then we combine this to form or to get the top branch. Okay? So our updated node this is H1, I1, T1 plus 2. Supposedly this will be 2, 2, 3. Okay? 2, 2, 3. This is the updated nodes list. And these are the assigned codes now. 0, 1, 0, 1, 0, 1, 0, 1, and then 0, 1. So this is the updated nodes list. Okay. So after you send T, okay, and then 0H, and then 0, 0, I, okay, then 1, 0, 1, 0, 0, S, okay, and 0, 0 underscore, or white space, sorry. So that's the, this is the current message that you have already sent, or this is the list of codes that you have already sent to the encoder. Okay. So now, so we are on TIHS underscore M, yung susunod nating letter. So here, since again M is the first time at this, sorry, ano yung message? This is mom, di ba? So, this is mom. Okay, so I pala yung susunod. So after the first underscore, so I, yung next message natin. Now, this is the second time that I would actually appear. Okay? So ang gagawin ngayon ni encoder niyo, okay, is to send the current code assigned to I. Okay, so since again second time na lalabas yung I dun sa ating message. Okay? Your encoder would send the code currently assigned to I, which in this case ito. Okay? So since ito yung I1 ninyo, that's the code for your I. 01. Okay? So isa-send niya ngayon yung 01 sa encoder natin. Okay? So, ayun. So, again, no, after your, medyo na-advance ko na siya. Okay. So, after, the encoder sends the code 01 kasi yun yung magiging current code nung nung I ninyo, 0 and 1. Okay? It now updates I2 from I1 to I2, being the second occurrence of I sa message natin. Okay? So, from there, let's create the nodes list. Okay? Dito sa bago nating code 3. By the way, kung H1 tsaka I2, this updates to 3 now. Okay? So, from there, let's create the nodes list of our code 3. So, you'll have underscore 1, then you'll have 1, ito, then S1, then H1, tas I2, T1, tapos 2, and then 3 at saka 3. So, ayan. Now, the problem with your nodes list is that this I2 is higher than T1. So, therefore, we have to interchange them. Okay? So, the new nodes list should be E underscore 1, okay, then 1, S1, H1, T1, then I2. Then, the next numbers here should actually will actually be changing kapag in-update natin yung yung ating code 3 natin. So, medyo insignificant pa to for now. Okay? So, ayan. Okay, so based on this updated nodes list na na-arrange natin, okay, let us update now our code 3. Okay? So, let's have E and then underscore 1. Okay? So, if we combine this into one node, you'll have 0 plus 1. So, you'll have 1. So, ito yun. Then, to the right of 1 is S1. Okay? So, pag ito, kinombine natin to, magiging 2 na kasi ito. Okay? So, therefore, ito yun eh. Ito yung 2 na yun. Okay? So, dapat pakita natin ngayon sa kanan ng 2, yung I2, T2, at saka H1. Okay? So, that would be I2 here, sa kaliwa ng 2. Then, we'll have T1, saka H1. That. Okay? Okay. So now, updating now the nodes above them. Okay. So this would be node 2. Okay, 1 plus 1 is 2. Then this is 2 plus 2 is 4. Okay, and then the top node there. Okay. So this will be now the updated code 3 with the following assigned codes: 0, 1, 0, 1, 0, 1, 0, 1, and 0, 1. So as you can see, this is called dynamic coding. Because actually the codes for each of the letters change depending on the frequency of their occurrence in the message. Nagbabago yung codes niyo habang nagbabago rin yung occurrence ng message niyo. Okay? So kaya siya tinawag na dynamic coding. Okay? Ngayon kasi ang maganda dito sa dynamic coding niyo is that masusundan to ng decoder niyo. Okay? Because the decoder itself can actually generate this code 3. Okay? And this nodes list. At the same time that it actually receives the messages. Okay? So, gagawa rin siya ng sarili niyang code 3 na ganito. Okay? So, ang kailangan lang talaga isend ng encoder is yung code words para sa message itself. Okay? And then, the decoder now, it is up to the decoder now to actually generate this code 3. Okay? Based on what the encoder sends. Okay? So, ayun. Now, let's continue. So, nasend na natin yung T. Okay? And then 0H. Okay? And then we have 00I. And then 100S. Okay? 000 then underscore or the white space. And then we have send 01 representing yung I. Okay? Now, the next letter that we will have to transmit, so THIS underscore I is S. THIS underscore I. So, yung isa-send natin susunod is S. So, for that, since we have already sent S before, hahanapin ngayon natin kung yung current code na assigned sa S, which it is found here. So, your S is found here. So, yung current code niyan is 11 1. So encoder now sends the message 111 to the encoder. Okay? And after that, it now updates S1 to become S2. And then, i-update nyo itong node na to, 1 plus 2. That would be updated to node 3 here. And then this 2 and 3 combines for 5. So magiging 5 to. So this is now our updated code tree after sending S. Okay? So, ayan. But if we, again, from this code tree, we create the nodes list now as E underscore 1, 1, S2, okay? Then you have H1, T1, I2, 3, 2, and 5. Which is, again, obviously, not arranged properly. Okay? So, the updated nodes list is to be arranged by interchanging itong S2 at saka itong T1. Pagpapalitin natin yung S2 at saka T1 natin. So, the new nodes list should be E underscore 1, 1, T1, H1, S2, I2, I2. Then, yung mga numbers dito actually will be insignificant as of now. Okay? Kasi magbabago naman yan at the end. Okay? So, ayun. Now, this being your updated node list, let's update now your code tree. Okay? Update natin yung code tree ninyo. So, we start with E. Okay? And then, underscore 1. So, if we combine this into a node, that becomes 1. Again, 0 plus 1. So, that's 1. Ito yung 1 na yun. Now, to the right of 1 is T1. Okay? So, if we have T1 here, okay? If we combine these two nodes, this becomes 2. Ngayon, itong 2 na to, should be on the right of this. Okay? Nasa kanan itong 2 nitong mga nodes na to. Okay? So dapat we locate I2, okay, S2 and H1 to the right of these two. Okay? So now we add these two nodes to have this as 4. These two nodes to have this as 3. Okay? And then this would be your top layer or top node. So this will be now our updated code tree with the following assigned codes. So we'll have 0 here. Zero, 1, 0, 1, 0, 1, 0, 1, 0, 1. So this is now the updated code after sending S. Okay? So now we send THIS underscore IS. Okay? We send now the second underscore. So these are the messages that we have already sent, no? Again, T, okay? 0, then H, okay? 0, 0, then I, okay? And then, I think this is 1, 0, 0S, okay? Then after that, we have 0, 0, 0, okay, underscore. Okay, next, we have sent 0, 1, representing yung repeated na, yung second I natin. And then, we have sent 1, 1, 1, representing yung second occurrence ng S natin. Now, we'll be sending another underscore character. And the code that currently the underscore character or the white space character is assigned the code 1, 1, 0, 1. Okay? It is currently assigned as 1, 1, 0, 1. So we will send now the code 1101 sa decoder ninyo. And that means the underscore character. Okay? So repeat na kasi siya. Okay. Now, that updates now our the number of occurrence of underscore to 2. Okay? Now, this node now is updated now as 2. Kasi this is 0 plus 2, so this becomes 2. Then 2 plus 1, this becomes 3. Okay? Then 2 plus 3, this should become 5. There. Okay? So, looking now at our code tree, so after sending now the second white space character and updating now the nodes in our code tree, we now generate the codes list, the nodes list. Okay? So again, reading from left to right and then bottom to top, we'll have E underscore 2. We have 2, T1, H1, S2, I2, 3, 3, and 5. So here, we can see that the nodes list are misarranged in a manner that itong dalawang to mas mataas dun sa T1 tsaka H1. Okay? So what we do is we interchange this with this one. Okay? So pagpalitin natin itong dalawang to. Okay? This number would be updated naman. Kaya tingnan muna natin kung ano yung mangyayari doon sa ating nodes. Okay? Basta this number would be updated once that we have already made the corrections to our code tree. So first listing the nodes, okay? After the rearrangement, we'll have H1. Okay? And then ayun, magiging 1 kasi to actually. Kasi as you can see, if you have to put this on the code tree, that's E and then H1. Alam mo na kagad na kapag kinombine mo, magiging 1 niya. So ito yun, yung part na yun. So magiging 1 yan actually. Now on the right of 1, you would have to locate T1. There. Okay? So you have T1 here. Okay? And then after T1, you'll have underscore 2. Okay? Then S2, I2, then 3, 3, 5. Although these numbers would be updated later on. Okay, so again, this is 1, ito yun. Then T1 to the right of 1. So pag ito, kinombine natin on a node, this becomes 2. Okay? Now this 2 must have been this number. So instead natin yan, dapat maging 2 yan. Okay, let's see. By actually placing I2 to the right of that 2, and then S2, and then underscore 2. Okay? So, ayun. But again, my code tree will run out of space. So, ayun na. Again, ito, mag-update yan sa 2. Okay? This will update to the number 2. Ito yun. Bale. So, we combine this 2. Okay? And have the node 4 here. Okay? We also combine this to have the node 4 here. And then combine these two nodes of 4. So we have 2 nodes of 4 here to get to the top of the tree. So this is now our updated code tree. Okay, with the following assigned codes now. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay? So I hope that you are seeing the pattern on how the dynamic Huffman coding is performed. Okay? And again, let's continue on. Okay? So after this THIS underscore IS underscore, the next letter here is N. So we have THIS underscore IS underscore M. So we're at this point. Okay, so again, currently we have sent the following messages or code words T, 0H, okay, and then 00I. Then we have 100S. Okay, and then 00 underscore 0, 000 underscore white space. Okay, then we have 01 representing the second occurrence of I, 111 representing the second occurrence of S, and 1101 representing the second occurrence of the underscore character. Now, in this case, your M appears for the first time. Okay, it appears now for the first time. So since this the appearance of M is for the first time, okay, the code to be sent there would be the code for E. Okay, so that code would be 1 1 0 0, and then the ASCII code for M. Okay, so you'll have here 1 1. The code to be sent next after this is 1 1 0 0 1 1 0 0, and then the ASCII code for M. Okay, now we update now the code tree after sending the M, okay, to the decoder. We update the code tree, okay, by having here E, and then M1, since M appears first on our message, and then these two combines for the node of 1. Okay, but this node, this is 1 plus 1, this node updates to 2. Okay, and then this node updates to 2 plus 1, so it updates to 3. Then 2 plus 3, this one updates to 5. That. Okay, so again, from this nodes list, from this code tree, we generate the nodes list. So you have E, M1, 1, H1, 2, T1, underscore 2, S2, I2, 3, 4, and 5. Okay, so as we can see on our nodes list, this 2 and this T1 is misarranged, so we have to interchange them. Okay, so that our nodes list becomes or is assigned with increasing numbers. Okay, so the new nodes list would become E, M1, 1, H1, T1. Okay, now these two might not be 2 anymore later. Okay, it depends on actually on what the nodes under it are, the values of the nodes under it are. Okay, so you have, but after that 2, you'll have underscore 2, S2, I2, 3, 4, and 5. Again, these numbers might change. Okay, now let's construct the code tree for this. Okay, this nodes list. So we start with the bottom layer of our code tree. So you have E, and then M1, which when we combine becomes node 1. So ito yun. Okay, and then to the right of that one is H1. Okay, which as we can see, we can combine these two. Okay, and would generate the node 2. But this 2 should have T1 at its left. So ngayon yung T1 dito nilalagay. T1. Okay? And then pag kinombine natin yan, that becomes the node 3. But this node 3, ito yun, okay, would have the following to its right. Itong I2, so ito, I2, you have S2, and then you have underscore 2. Okay? So you combine these two to make the node 4. You also combine this to make the node 5, and then you combine these two to get at the top of the tree. So this is now our updated code tree after sending the M character or the M message. Okay, with the following assigned codes 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, and then 0, 1. Okay, so at this point, I think I can leave now with you the next steps. Okay, the next steps of the algorithm. Okay, so again, let's review. At this point, we have already sent THIS underscore IS underscore M. So yung next na isa-send nyo na, at this point, these are the codes that have been sent to your decoder. So you'll have the ASCII code for T, okay, 0, then the ASCII code for H, okay, 0, and then the ASCII code for I, tama? 2 zeros pala, 0, 0, okay, and then the ASCII code for I, okay, 0, 0, and then the ASCII code for I. Then next, we have 1, 0, 0, and then the ASCII code for S. Then we have 0, 0, 0, and then the ASCII code for the white space character. Okay. And then you have 01, representing the second occurrence of I. Next you have 111, representing the second occurrence of S. Okay, and then you have 1101, representing the second occurrence of the white space character. And then, finally, you have 1101, okay, and then the ASCII code for, 1100 pala. Okay, 1100, and then the ASCII code for N. So, again, at this point, ito na yung na-send nating mga letters. These are the codes that have been sent to the decoder. And currently, this is our code 3. Ito na yung code 3 natin. This is the current code 3. Now, I would like you to if you already have understand the algorithm, you may test your understanding by actually trying to generate the message to be sent or the code to be sent for the last two letters and the updated code 3. Okay? The updated code 3 for after sending those two letters. Okay? So, actually, nandito naman siya. So, ma-check nyo kung tama kayo. So, ito yung ito yung O. Okay? And this is your for the second M. Okay? So, this will be the final this will be the codes. Okay? Sent to the encoder that represents this. Okay? And remember that the decoder at the receiving end actually had the same code 3 or would be able to generate this same code 3 after receiving these messages. Okay? So, yun yung kagandahan ngayon dito sa sa ating dynamic Huffman coding. That is, the encoder and the decoder independently works on the statistics for your messages. Okay? So, yun, the decoder does not need to wait for the encoder to generate the source statistics. Okay? So that para makapag-decode siya. So, as the decoder receives the letters or the codes for the letters, it actually updates its own code 3. So therefore, it can actually decode its own or it can actually decode the message using its own analysis of the message. Okay? So there. Now, so I again cut the video here, right here. Okay? Because the video is now around 1.5 hours. Okay? And on the next video, we will discuss, okay, the Lempel-Sieve algorithm. This Lempel-Sieve algorithm is one algorithm that actually generates fixed length codes. Okay? But this is also dynamic in the sense that the Lempel-Sieve algorithm generates code or synthesizes code based on the incoming message. Okay? As the message comes. Okay? So dun siya nagsisynthesize ng code. Okay? So that's the point of our discussion for the next recorded video.